This is our quiz coming up on circles and ellipses. So we've covered mainly the two topics, circles and ellipses. Circles, pretty straightforward. There's a lot of complexity, a lot of moving parts to the things about an ellipse you got to be really solid with. So things we started out with in this unit, we started out with completing the square. So completing the square. Keep in mind when you've got something like, x squared plus 4x, you're going to take half of this number, which is 2, and you're going to have to add 2 squared to make that a perfect square. When you have something like negative 2x squared plus 6x, in order to make that a perfect square, you have to factor out the coefficient. So that's negative 2x squared minus 3x, and then from there you have to add, 3 halves squared. That's what it's going to take to make this a perfect square. And remember, if this is an equation, you have to really keep in mind, what did you just do? It looks like I added, that's 9/4, but it's multiplied by negative 2. So really what I did, I subtracted 9/4. So if I subtract 9/4 from the left side, I must also subtract 9/4 from the right side, okay? You've got to be very cautious about completing the square when you have something factored out. So you've got to be really solid on that. That's going to come up 3 or 4 times in this quiz. Equation of a circle. You know that equation, what you need to graph it. Other things, if I give you a circle, you give me the equation. If I give you the radius and a point on the circle, or if I give you the endpoints of the diameter, be very comfortable. Different scenarios I give you, and you come up with the equation of the circle. Know the equation of the ellipse. Be very solid on all the components, the center, the major axis, the minor axis, if it's vertical, if it's horizontal, the foci, which are the focus points, or 2 of them, the focal length, that's the distance from the center to the focus, the vertices and the co-vertices. So graphing, if I give you an equation of a circle or an ellipse, you should be very comfortable graphing those. Given the graph of a circle, give me back its equation, okay? And this is going through some of the details of what I just said. Given the center and the radius of a circle, give the equation. Given a radius and a point on the circle, given the diameter endpoints, all of these give me the equation, a center and a tangent line. If I graph an ellipse, can you give me back the equation? If I give you the center of an ellipse, vertices and co-vertices, can you give me back the equation? If I give you the vertices, co-vertices, can you give me the ellipse of the equation? You have to find the center in that case. If I give you the center, a vertex, and a focus, or if I give you the center, a co-vertex, and a focus, come back with the equation of the ellipse. So we'll work through some examples of some of these as we go forward. So let's just take an example. Solve by completing the square. Okay, so this is x squared plus 5x equals negative 4, okay? In order to complete the square, you look at this term right here, the 5x. So I need to add 5 halves squared. So if I add that to the left of the equation, I must also add that to the right. Now I know that the left side is a perfect square. 5 halves plus 5 halves equals 5. So this is x plus 5 halves squared. So this equals negative 4 plus, 25 over 4. So with a common denominator, this right side is, this is what, negative 16 over 4 plus 25 over 4. And so this becomes x plus 5 halves squared. 25 minus 16 is 9. So this is 9/4. So this means that x plus 5 halves equal plus or minus square root of 9/4. Let me move over here to the margin. So I'm going to come back up here. So this means that x plus 5 halves equal plus or minus 3 halves. So x equals negative 5 halves plus or minus 3 halves. So negative 5 halves plus 3 halves, that's negative 2 halves. And negative 5 minus 3, that's negative 8 halves. So that's negative 4. Number 2, similar, but you see that I've got a non-1, I've got a 2 in front of the quadratic term. So you must factor whatever that number is. So 2x squared plus 2x, and I'm going to move the negative 1 to the other side. Okay, double check yourself. What's 2 times x squared? That's 2x squared. 2 times 2x, that's 4x. That is factored correctly. Now to complete the square, what is half of 2? That's 1. So I'm going to add 1 squared to both sides. Well, sorry, not both sides. If you look at what I did, it looks like I added 1, but it's multiplied by 2. So this is in effect adding 2 to the left side of the equation. Okay. Now, if you didn't catch that, you would think I added 1. That would make this 0 on the other side. Completely changes the problem. So this is 2 times x plus 1 squared equals 1. That means that x plus 1 squared, divide both sides by 2, equals 1/2. So x plus 1, take the square root of both sides, equals plus or minus square root of 1/2. That means that x equals negative 1 plus or minus square root of 1/2. Number 3, this is a circle. Identify the radius and center, then graph the circle. Okay, the center is negative 1, positive 3. And then we know that r squared in this case is 16, so the radius is 4. Circle centered at negative 1, 3 with a radius of 4. Negative 1, 3. There's the center to my circle. If my radius is 4, count out 4 in every direction. So it goes through this point, right here, here, and here. And that is it. Negative 1, 3, radius of 4. Next problem. I give you a circle and you come back and tell me where the center is. So it looks like the center is right here. Double check. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 4, 5. So I know the radius is 5. The center is negative 4, 3. Therefore, the equation of this circle is x plus 4 squared plus y minus 3 squared equal r squared, which is 25. That's the equation of this circle. Give the equation of the circle with a center 5, 2 and a point on the circle at 9, 2. So this is the center of my circle. And what you're going to see on this quiz where it says space to show your work, this means I'm not really grading this graph, but it's just there to help you if you need it in finding this equation. So if the center is 5, 2 and the other point on the circle is 9, 2, so that means my circle looks like this. That means that I can figure out the radius, okay? So if 5, 2 is on the circle, and sorry, I just did that wrong. I did the wrong point. So back up. 5, 2 is the center, and 9, 2, which is right here, is a point on the circle. So that means the circle does this. So anyway, back up. There's a mistake, but you can fix it. So what is the radius here? This is 1, 2, 3. So the radius is 3, and the center is 5, 2. So in this case, this equation is x minus 5 squared plus y minus 2 squared. If the radius is 3, that has to equal 9. Give the equation of the circle with a center at 0, 4. There's the center of my circle. and with 3, 0 as a point on the circle. 1, 2, 3. So this is a point on the circle. So what I got to figure out is what is the radius. So what is the radius? So the circle does something like this, okay? So I got to figure out what the radius is. Now, what I can do, I can use the distance formula, okay? So the distance formula, so remember our distance formula is the square root of, x1 minus x2, we've got 2 points, plus y1 minus y2. So I can use the distance formula, or I can just look and say this is a triangle. So this is a triangle. So what is the distance, the vertical distance? That is 4. What is the horizontal distance? That is 3. So this is Pythagorean theorem will tell you that 3 squared plus 4 squared equal c squared. So that's 9 plus 16 equals c squared, so 25. C squared, c is equal to 5. So that's a 3, 4, 5 right triangle. Same thing, if I had just used the distance formula, I'll get the same thing. The distance is going to be the square root of the difference in your x's plus the difference in your y's squared. So this is the square root of 9 plus 16, which is square root of 25, which is 5. So now all of that to say, I do know the center and the radius. So if the center is here, this is x minus 0 squared plus y minus 4 squared. If the radius is 5, this has to equal 25. Give the equation of the circle with a center at -4, -2. So here we are at -4, -2, and a tangent line at x equal -3. So this is -4, -2 at x equal 3. If I were to draw a line, that's the line x equal 3. So if this is the center, what my circle does is something like this. So what I need to figure out then is what is the distance from here to here? And you can just count those out. That is 1, 2, 3, 4, 5, 6, 7. So the radius is 7. So use that center, and you know that the equation is x plus 4 squared plus y plus 2 squared equal the square of the radius, 49. Now, write the equation of this circle in standard form. This is one of those cases where you got to know to use completing the square, okay? So to complete the square, this is going to be 2. I'm going to factor out, you have to factor out that coefficient. X squared minus 2x, I'm going to leave some space, plus I got to do the same thing with y. Y squared plus 4y. Instead of the minus 10, I'm going to say equals 10. Okay, double check. Look at what I factored out. 2 times x squared, that's 2x squared. 2 times negative 2x, that's negative 4x. Go to the y's. 2 times y squared is 2y squared. 2 times 4y is 8y. Okay? So if I look at this, then what is half of this number? That's 1, so I need to add 1 squared to there. Half of this number is 2, so I need to add 2 squared in this case. But how did I really change the equation? This is adding 2, so I'm going to write a plus 2 over here. And then if I look right here, this is adding 2 times 4, this is adding 8. So I need to add 8 to this side. So now what I get is 2 times x minus 1 squared plus 2 times y plus 2 squared equal, this is what, 12 plus 18, this is 20. It's not quite in the right form, so let's just, we could have done this to start out the problem, factor it out of 2. If I divide everything by 2, here I get x minus 1 squared plus y plus 2 squared equals 10. Now in this case, I've always told you, simplify wherever you can. We could have started out with this problem. We could have factored out a 2 of the entire problem. X squared minus 2x plus y squared plus 4y minus 5 equals 0. Then you could divide both sides by 2, and what you'll see is you've got what looks like what you did with completing the square. That would have simplified the problem somewhat, but you'll get to the same answer. Okay, but if you can't factor something like a 2 out of the entire equation, you must always factor that quadratic term. Now we're moving on to ellipses. Write the standard formula for an ellipse: x minus h squared over a squared plus y minus k squared over b squared equals 1. So if I know that the center is at hk, what it will also help me, even though I didn't ask it here, a is 6 and b is 7. That will help me in this problem. Where is the center to this ellipse? This ellipse is centered at -2, 3. Okay, then I'm going to just go ahead and graph that. -2, 3. That is the center of my ellipse. Where are my vertices? Okay, my vertices fall on the major axis. The major axis is going to be the one that is the larger of the two. So this will be my major axis. Okay, so that's going to tell me how to find the vertices. Well, if I look at b is equal to 7, that means I have to go up 7. 1, 2, 3, 4, 5, 6, 7. Sorry. Right there, that is a vertex. Okay, and so what is that point? That is -2, 10. So this is what, 3, 4, 5, 6, 7, 8, 9, 10. Don't let the way the graph there looks fool you. But so -2, 10 is one of the vertices. Well, there's a matching one if I go down by 7. 1, 2, 3, 4, 5, 6, 7. Right here, that is -2, -4. Okay. So that's how I find the vertices. So that is another vertex. This is the center. How do I find the covertices? Well, that's going to be along the minor axis. So I need to go a distance of 6 along the vertical. So 1, 2, 3, 4, 5, 6. That's a covertex. 1, 2, 3, 4, 5, 6. That is another covertex. Those points are 4, 3. And 6, 7, 8, -8, 3. Those are the covertices of the ellipse. So at this point, I have everything I need to graph this ellipse. So it looks like this, because you really don't need the foci to graph it, but I'm going to ask you about it. So that is the equation of this ellipse. Now, how do I find the foci? I have to remember that the focal length is c squared equal absolute value of a squared minus b squared. So that means that c squared is the absolute value of 36 minus 49, which is 13. So c is equal to the square root of 13. Okay. So if you need to know what the square root of 13 is to help you with your graph, you can just use that to figure out. So square root of 13 is about 3.6. Okay. So that's about 3.6. So that means if I'm at my center, I go up 1, 2, 3, somewhere about 3.6. That's going to be a focus. Go down 1, 2, 3.6. That is another focus. And I know they have to be on the vertical. So what is that point? So that point is -2. So the first one is -2. And then the y value is going to be 3 plus square root of 13. And there's another one at -2, 3 minus square root of 13. Those are the foci for the graph. The major axis is vertical. What's the length of the vertical axis? The length of the vertical axis will be twice that. So the length of the vertical is 14. The length of the minor, in this case, is the horizontal. It's going to be twice this number right here, which is 12. And that's it. So guys, there's no hiding. There are a lot of little details. You have to be real solid. If you're confused about, what this formula is or what C means, then it's going to be a struggle. You got to be very solid on all these definitions for the ellipse. Write this ellipse in standard form. So this is another example of I need to know how to complete the square. So if you look at this, I've got to factor out the 5. X squared minus 6x, and then I leave some space. Plus, factor out the 4. Y squared plus 4y, leave some space, equal negative 41. Now to complete the square. In this first one, I've got to add half of 6 squared. This one, the next one, I have to add what is half of 4, that's 2 squared. Now, what did I really do? So in this case, that is 9 times 5. So I added 45. I must do that on the right side. If I look at the next one, this is 4 times 4. I added 16. So I have to add 16 to the other side. Okay? So what I come up with is 5 x minus 3 squared plus 4 y plus 2 squared equal 45 minus 41 is 4. 4 plus 16, this is 20. Okay. Now, what's the standard form? The standard form of an ellipse is set equal to 1. Okay. So what I need to do now is I got to figure out if I divide everything by 20, look at the first term. Okay. What is 20 divided by 5? That is 4. So this is x minus 3 squared over 4 plus this is y plus 2 squared over 5 equal 1. And there I'm done. So that is the ellipse with the center at 3, negative 2. And this is a vertical ellipse because the vertical is a larger number in the axis. Write the equation of the ellipse centered at 1, 1 with a vertex at 1, 7 and a co-vertex at 5, 1. So vertex is at 1, the center is at 1, 1, which is right here. There is a vertex at 1, 7. So that's a vertex, that's the center, and a co-vertex at 5, 1. Okay. So here I just got to be real solid on my definitions. So if there's a vertex that's straight up vertically from the center, we know this is a vertical ellipse, okay? And by definition, from the center to the vertex, that's going to be B. From the center to the co-vertex, that is going to be A in this case. So what are those numbers? So you just count 1, 2, 3, 4, 5, 6. B is equal to 6, and A is equal to 1, 2, 3, 4. And the center is 1, 1. So the equation of this ellipse is x minus 1 squared over A squared plus y minus 1 squared over B squared equal 1. Write the equation of the ellipse in standard form that has these vertices and co-vertices. So vertices are at negative 4, 5. So that's a vertex. And at 2, 5, that's a vertex. So that means this is a horizontal ellipse. So where's the center going to be? 1, 2, 3, 4, 5, 6. So it's going to be halfway in between. So I know that's going to be the center right there. The co-vertices are at negative 1, 7. So negative 1, 7 and negative 1, 3. Okay. So by definition, the distance from here to here, that will be A. And then the distance from here to here, that will be B. So what is A? A is 3. B is 2. And my center is negative 1, 5. That's all I need for this. X plus 1 squared over a squared plus y minus 5 squared over b squared equal 1. Now, this one gives people more trouble, but it's just being very solid with your definitions. Write the equation of the ellipse with a center at 2, 4, covertex at 2, 10, focus at 2 plus square root of 13, 4. Okay? So again, if the center is 2, 4, 1, 2, 4, okay, that is the center of my ellipse. A covertex at 2, 10, that is right here. So this is a covertex. That's the center. Okay. And they just got to figure out, then they give me what a focus is. So square root of 13 is, what is that? About 3.6. So this is 2 plus 3.64. So this is about 5.64. Okay, that's about where this is. Okay, so that tells me there's a focus at about 5.64, somewhere in there is a focus. Okay, so what I'm missing is the vertex. Okay, so what I already know, the distance from the center to the covertex, that's going to be b. 1, 2, 3, 4, 5, 6. So I know that b is equal to 6. Okay. Now, by definition, the distance from the center to the focus, that is what the definition of C is. So what's the distance? What's the distance from the center to the focus? So from 2, 4 to 2 plus root 13, 4, that distance is just the square root of 13. Okay? So what I need for this ellipse, I need to know the center. I have that. And I need to know A and B. Well, in this case, I know C, but I do not know A and B. But I do know that C squared equal the absolute value of A squared minus B squared. So that means that C squared, that means the square root of 13 squared is equal to the square root of A squared minus 36. Okay. Now in this, now in order to solve this, I need to get rid of these absolute value signs. So you have to do a little bit of thought process. If the covertex is vertical, and then the vertex is going to be on the horizontal, that means that A has to be greater than B in this problem. Okay, this has to be a horizontal ellipse. So if A is greater than B, that means that this is going to be a positive number inside the square root sign. So I know that 13 is going to be A squared minus 36. Okay, and I know that because A squared minus 36, A is greater than B, this is a positive number. So this means that A squared is equal to 49, or A is equal to 7. And I am confirmed here that A is greater than B. So now I have everything I need. I've got the center and I have A and B. So this is x minus 2 squared over A squared plus y minus 4 squared over B squared equal 1. And that's it, okay? Guys, a lot of things, especially this thing about deriving equations from ellipses, because there are probably 5 or 6 different ways I can give you the information and expect to get back the equations. You got to be really solid with all of your definitions and the graphing for the ellipse.